Your brain is the most energy hungry organ in your body. It makes up only about 2% of your body weight, yet it consumes nearly 20% of all the energy your body produces. Every bite you take is literally becoming part of the machine that controls your thoughts, emotions, memories, and decisions. And unlike your muscles, it can't simply slow down when fuel runs low. Every second, about 86 billion neurons are firing electric signals, allowing you to read these words, recognize familiar faces, store memories, and even wonder what you will eat for dinner. But here is the interesting part: the brain does not produce its own fuel. Everything it needs has to come from the food we eat. So, how does a slice of bread become a memory? And why can a sugary snack leave you feeling energized one moment and exhausted the very next moment? To answer those questions, we need to follow a single bite of food on one remarkable journey from your plate to your brain. The journey begins from the moment food enters your mouth. Chewing breaks it into smaller pieces while enzymes in your saliva begin digesting carbohydrates. Once swallowed, the food travels down the esophagus and into the stomach. Continue breaking it apart. From there, it moves into the small intestine, the body's primary nutrient absorption center. Here, carbohydrates are broken into glucose, protein into amino acids, and fats into fatty acids. These tiny molecules pass through the intestinal wall and enter your bloodstream. But reaching the brain is not as simple as taking a ride through your blood. Most organs are happy to receive whatever the bloodstream delivers. The brain is not. Its cells are far too delicate. To protect them, tiny blood vessels in the brain are packed tightly together, forming a protective layer known as the blood brain barrier. Think of it as an extremely strict security checkpoint. Glucose is allowed through, oxygen is allowed, certain amino acids are also allowed. Many bacteria, toxins, and harmful molecules are stopped before they even reach your brain tissue. Without this barrier, chemicals that are harmless as well in the body could interfere with the electrical activity of neurons. Only approved nutrients are allowed to continue the journey. Once nutrients enter the brain, they are immediately put to work. The brain is made up of roughly 86 billion neurons, each connected to thousands of others. Together, they form trillions of connections called synapses. Every thought, memory, movement, and emotion depends on signals traveling across these connections. Sending those signals requires energy, lots of it. That's why glucose is the brain's preferred fuel. Inside neurons, glucose is converted into ATP, the molecule that powers almost every cellular process. Without enough ATP, neurons struggle to maintain the electrical signals that allowed them to communicate. But energy is only part of the story. Neurons also need raw materials to send messages. Neurons don't touch each other directly. Instead, they communicate by releasing tiny chemical messengers called neurotransmitters into microscopic gaps called synapses. These neurotransmitters influence everything from attention and motivation to memory and mood. But your brain can't manufacture them from nothing. It depends on nutrients from your diet. For example, the amino acid tryptophan helps produce serotonin, which plays a role in mood and sleep. Specialized neurons convert tryptophan into serotonin through a series of chemical reactions. And this is where food begins connecting with emotions. When serotonin levels and signaling are properly regulated, it helps your brain manage stress responses, maintain stable moods, and support healthy sleep cycles. This is one reason researchers have explored links between diet quality and mental well being. Diets rich in whole foods such as fruits, vegetables, whole grains, nuts, and sources of healthy protein provide the nutrients needed for these complex chemical processes. In a very real sense, part of your lunch eventually becomes part of the conversation happening between your brain cells. Not all carbohydrates behave the same way. Whole grains, beans, vegetables release glucose slowly, giving neurons a steady supply of fuel. Refined sugars enter the bloodstream much more quickly. That rapid increase triggers the release of insulin, causing blood sugar to rise and often fall just as quickly. For many people, this can lead to a brief burst of energy followed by fatigue, reduced concentration, and renewed hunger. The brain has not stopped working, its fuel supply has simply become less stable. While glucose powered neurons, fat help build them. Nearly 60% of the brain's dry weight is fat. Much of that fat forms the membranes surrounding brain cells. One group of fats, omega 3 fatty acids, help keep these membranes flexible, allowing neurons to send and receive signals more efficiently. Rather than serving as fuel, these fat help maintain the structure that makes communication possible. Finally, there is another unexpected player in the story. The digestive system is home to trillions of microorganisms known as the gut microbiome. As they digest food, these microbes produce vitamins, short chain fatty acids, and other molecules that influence inflation, hormone activity, and signals traveling to the brain through the vagus nerve. Scientists are still discovering how this communication works, but it's becoming increasingly clear that your gut and brain are in constant conversation. Your mood is not controlled by emotions alone, it's also influenced by the chemicals your brain makes, and those chemicals depends in part on what you eat.